So now we're going to briefly discuss the time complexity of the CYK algorithm. Happens to be the case that it's cubic time and the length of the string. The full derivation of that is in the solutions, but I'm just going to give the intuition as to why. So when we run the CYK algorithm, we basically build up this big triangle of sets, right? How many sets are there to compute in total? Where there's n sets on the bottom, plus n minus 1 sets on the next row, plus n minus 2 sets on the next row, plus blah blah blah, plus one single set on the top. So what's the sum of numbers from 1 to n? Well, that's just n times n plus 1 on 2, which is O of n squared, right? This thing's a quadratic. And when we compute each set, how much work is there to do? Happens to be the case that it's a linear amount of work. And why is that? Well, when you compute a particular set, say x13, you have to check all the sets beneath it in a column, working up, and all the sets below it in the diagonal, working down. When you compare two sets, you have to check every possible combination of variables that are in there, but the number of variables, at most, could be all of them, isn't dependent on n. So there's really an O of 1 comparison between these, and an O of 1 comparison between these that isn't dependent on the string length. So as the sets go up and up and up, we basically have to do more work, but in the absolute worst case, we have to compare all these sets here, which is n minus 1 sets, against all these sets down the diagonal, which is n minus 1 sets. That gives us two n minus 1 sets to compare, which is clearly O of n. So in the absolute worst case, you have to do a linear amount of work for each one of these sets, and a linear amount of work times a quadratic amount of sets is going to be a cubic number of sets. See the tutorial solutions for the full derivation in detail.